Alright, hello everyone, this is John, and today I'll be providing another video on how to create and edit interaction plots in RStudio. I've already produced a video on how to create interaction plots, but this will really just be an extension of that other video. The difference here will be that I'll show actual analysis that one will want to produce before creating an interaction plot, but then show some more advanced features to creating interaction plots that one might want to consider, and then finally show a two-way interaction plot and a three-way interaction plot. The first video only showed a two-way interaction plot, which we will replicate here, but then I'll extend that by doing a three-way interaction plot as well, as the plotting procedures are a bit different and the visuals are different as well. So in that first video, we created the following interaction plot. There's a lot of changes we made in the code to make it look the way it is. So for example, we changed the labels on the Y and X axis. We changed the range on the Y axis to go from 1 to 10. We added a title. We relabeled the legend. We recoded the legend. And for the X axis, we provided labels as well. So we're going to replicate a lot of these things in this other plotting technique, but then I'll show you some other things you might want to consider as well. So we're going to jump right into RStudio, and here in R we have our data already loaded. Pretty much the research question is the same as the last video. For this first part, this two-way interaction, we want to see if there's an interaction between men and women in the amount of close friends they report at work and their overall job satisfaction. So we sort of have a hypothesis here that there will be difference between men and women in the amount of close friends they have at work and what their overall job satisfaction will be. So the data set is pretty straightforward. We have sex, which is gender, which is coded 0 to 1. We have friend, which is how many close friends they report at work. And then we have job satisfaction, which is their overall job satisfaction. I've added another variable here as well, which is called age, but we won't be adding age into the model until a bit later when we run that three-way interaction procedure. So first things first, we're going to do part one, the two-way interaction, just like in the last video. If we want, we can look at the head of the data just to make sure we got all the variable labels that we need. And then we're going to actually, for step 2 here, is actually run an interaction moderator analysis. This is a form of regression. We didn't run this in the first video, so we don't actually know if the interaction that was plotted here is significant or not, but we're going to test that right now with this following regression or interaction analysis. So our dependent variable is job satisfaction, and then our independent variables or predictors are friend and sex. Sex being gender, friend being how many close friends they report at work. So we're going to run this. It's going to be called mod1. So you can see right now in the environment, there's mod1. But we need to ask for the summary of mod1 to get those results. So let's run it. And here we are. If you look at friend sex, that's the interaction term. This is the interaction effect. It is significant, and it's quite significant, below 0.001, which is great. So technically speaking, the interaction that we see here is different, and that we can assume that females who report more friends at work have a higher overall job satisfaction than males. That's pretty much what the effect is telling us. But what we're going to do now is run a new interaction plot procedure, one that looks a bit different, a bit visually aesthetic in a different sense, and one that people might want to consider just because it's a little bit more sophisticated than the standard interaction plot function. So here's step 3. We're going to run a new two-way interaction plot. One thing I'd like to mention is in that first video, there was technically no packages required in order to run the interaction plot. The stats library is already a built-in function in R, so you can run interaction plots with very little, with quite ease, really. You don't need much in order to do so. But for this plotting procedure we're going to do, there's actually 3 libraries that you need. So these are the three libraries: sjplot, sjmisc, and ggplot2. I'm going to run those now, and then we're going to begin looking at the actual plot that we're going to create. So in our last video, it's called interaction plot. Here it's called plot model. And plot model, the code's a bit different than interaction plot. We actually have to use a modeling procedure in order to run this type of plot. So we already had our modeling procedure, which was up above, which is the interaction effect that we are testing, called mod1. We have to include that in the code, mod1, and then we have to give it a type. And type is really, I have it here below, is the analysis and plotting procedure that you want performed. So if you go to type, F1 help, it'll show you a list of options that you can consider depending on the type of plot and procedure you want to take into account. Here I'm using int, which is interaction. I have an interaction effect, so I want to have an interaction plot created. And here are the terms. You just have to sort of say what the terms are. So it's friend and sex, and it just knows that these terms are there. So it has friend pretty much along that x-axis, and then sex, which is going to be the grouping variable. So let's run plot 1. Let's highlight it and run. And here's the new plotting procedure that we're using. So you can see right away, looking at this plot compared to the old plot, there's some differences involved, right? And that's why this might be a plotting procedure one might want to consider using for interaction plots. But you can see that there's a lot of things we need to change, just like we did in the last video. We're probably going to want to relabel our axes. We're going to want to relabel our legend, and then we're going to want to change some of these values on the axes and legend to be more meaningful for those who are going to view these plots. And of course, we're going to change the title as well. So that's where step 4 comes into play. We're going to actually start editing. We're going to start editing the two-way interaction plot, which is plot 1. So there's some options to consider. First thing is type, which we already did, which is the interaction. Here's type, int. Like I said, if you use F1 on type, type F1 help, you can look at other options, but that's going to stay the same. Axis title is the label for your y-axis. Just like in the last video, we're going to call it overall job satisfaction. Axis lim, which is the range of values along that y-axis. We're going to range it pretty much from its lowest value to its highest, which is going to be 1 to 10. You can see here it's ranging about from 5 to 9. We're going to change that so it captures the full length of the scale. And then the next one is title, and title is going to be literally the title for your plot. And I'll use the same title as in the last video, which is employees overall job satisfaction and close friends at work. And then finally we have legend title, which is literally going to be the legend title for your legend, and we're going to call it gender. And that's pretty much everything that we are going to do. So there's another step involved here, but I'm going to do that just momentarily. Let's run plot 2. We have to actually type plot 2 here. Plot 2. So let's run it. So already you can see some things have been changed. We got our title. We've relabeled our y-axis. We have it ranging from 1 to 10. And we've relabeled our legend. But one thing you probably noticed we did not label, which is the x-axis. To actually relabel the x-axis requires an additional line of code, which I have highlighted here. Once you've run plot 2, you're going to add another line of code called labs. And under labs, you're going to say x is going to equal close friends at work. Within the plot model function, there's no real way I know to edit the x-axis in this sense. So it's just easier to add an additional line of code on top so you can actually make that change. So if I run this now, you can see the x-axis change from friend to close friends at work, which is what we want. But of course, just like in the last video, there's some other things we want to change, and that's what we're going to do in step 5 here. Is we're going to start relabeling our values on the axis and legend. Right now for gender it's 0 and 1. It doesn't really tell the reader much on whether it's males or females to males, so that's something we're going to want to change. And then similar to the last video, we're going to re-edit the x-axis or relabel it. So instead of it being 0, 1, 2, and 3, we actually have labels there that are a bit more appropriate. So just like in the last video, you're going to run library car, because this is how we run the recode function. And we're going to recode the sex variable into a new variable called sex recoded, where 0 is going to equal male, 1 is going to equal female. So we can run that. And there we go. So technically now we have a new variable now called sex recoded. We can look. You can see it's pretty much here on the side here. Sex recoded, male, female. Looks good. But the next thing to do is if we're going to relabel our x-axis, there's a totally different method you're going to have to use for this plotting procedure that differs from the last video. Here, the plotting to do that change, you're going to use a function called levels. And levels, just like in SPSS, it's going to provide labels for your values. So instead of how sex recoded was completely created as a new variable, as a new string variable, levels does not create a new variable and does not alter the values that are within that variable. It in the background is just going to provide labels to those values, and that's it. So if you're familiar with SPSS, you will probably know that you have two separate windows, a variables window and a data window. This is technically using a variables window to create labels to your data. So here it's going to be very simple. 0 is going to be 1, 1 is going to be medium, 2 is going to be high, and 3 is going to be very high. So if we run this now, technically speaking, if we look at the friend variable, we won't actually see labels, as you can see here, because they're actually in the background, just like in SPSS. So friend here still has 0, 1, 1, 2, 3. Those variables haven't changed. They've just been given labels in the background. So the next thing to do is now rerun. Step 6 here is to rerun the two-way interaction plot. We're going to call this one mod 2 because there's been some changes that have been made to the data. Number 1, we've created a new variable for sex, which is recoded. But at the same time, we've provided labels to friend, which the model needs to take into account now. So if we run mod 2, we now have it in our environment. We technically don't need to look at the summary for mod 2 because the results are technically still the same. But we've created a new plot now, plot 3, which now accounts for mod 2. But pretty much everything else that is displayed in our plot is still the same. Same interaction type, same y-axis, same range for y-axis, same title, same legend, etc. So if we run this now, we should see some changes. And here they are. So for the x-axis, now it has labels instead of numerical values is what we want. And it hasn't altered the plot, which is great. And then for legend, we have male and female. And that's pretty much how everything you do for a two-way interaction plot using this procedure. The next thing we're going to jump into now is a three-way interaction plot. So a three-way interaction plot is literally following the same procedures as the two-way interaction plot. Why I want to show this is because the actual display for the plot is quite different compared to a two-way interaction plot. So for our three-way interaction plot, if I quickly jump up above, for part 2 here, the research question is still pretty much the same. We want to see if there's an interaction between men and women in the amount of close friends they report at work and their overall job satisfaction. But something else we're adding now is age. Does age also have some sort of interaction with men and women and the amount of close friends and job satisfaction? So that's exactly what we're going to do now, is we're just going to literally add age into the model and see what happens. So here we are. We're going to create a new variable now, or new model, which is model 3. Dependent variable still job satisfaction. And now we're going to look at friend by age by sex recoded. You could see here that the order of the interaction terms is important, or of these predictors, because that's really how the plot is going to sort of lay itself out based on this order. So originally it was friend by sex, but what we really want is friend by age by sex, because sex is still going to be our grouping variable. So we can run this now. And we can run the summary to see if it is significant. If we add age, does it actually significantly add something to the model? And if we here look at our three-way interaction, which is below, it is significant. So there is a significant effect taking place. And now we can plot this significant effect to see really what it is suggesting about age on our interaction. So here we are. We're going to do plot 4, which is model 3. Everything is still the same. We still have the same title for the y-axis, same range for y-axis, same title. We're going to have a title here, which isn't correct. Let me quickly grab the title from above. But we have our title here. I obviously did not change that title. And what we're going to do, though, is run this plot as well to see how it looks. One thing that I want to mention right away that wasn't included in the other plots is this new step here, which is MDRT values. And here it says quart. The idea is with age now being included in the model, because age is a scale, we can actually ask it to display things in certain dimensions. So by typing in quart, it's actually going to split it into quarters, and you'll see momentarily what that's going to look like. But if you want to look at other options for how you want to split and display the data, type in MDRT values F1 help, and it'll show you a couple of options you might want to choose from. But here we go. We're going to run this and see what it looks like for our three-way interaction now. And here we are. Let's just zoom in a bit. So what it's showing is we have our close friends at work, low, medium, high, and very high. We have our overall job satisfaction, which ranges from 1 to 10. But then you can see here, we have two plots actually. We have a male plot and we have a female plot. And all these lines that it's showing within this plot are being broken up based on the age of employees. And because we selected quart, it's breaking it up into pretty much quarters, which is now 29.75, 39.5, and 49.25. So that's pretty much the method it is using to restructure the data for us. What I'm going to show you is really a method to recode the age variable to perhaps set it up in a way that you would rather it set up the data or display the data for you. So what you're going to do is under recode age, one thing I like to do is find that minimum and that maximum, so I know really what's the range of data that I'll be working with. So if I run this, it's pretty much saying here that the lowest age is 20, but the highest age is 59. So I've already gone ahead and recoded this variable, and I am going to recode it because it's going to become a new variable which I'm going to use. But what it's pretty much saying here is that for age recoded, I'm going to take that original age variable, and I'm going to really just create two groups out of it. Anyone between the age of 20 to 39 will be in the 20 to 39 year olds. Anyone between the age of 40 to 59 will be in the 40 to 59 year olds. So pretty much all I have to do now is run this. I technically have a new variable which we could look at really quickly. You can see there it is on the side, and I'm going to use that variable to redisplay things on the plot. So of course, with any change that you're making to the data, with any new variable you are creating, you're going to have to rerun your modeling procedure, your interaction effect, to account for these changes. So you can see here now it's going to be friend by age recoded, not just age, and sex recoded, to really look at that, to include that now within our plotting procedure. I'm going to run that. It doesn't really matter to look at the summary because once again we know what the results are. We're just trying to display things in a format that might be more aesthetic to some. So here we are again. There's the title that I did not change. And we're going to run now a new plot. And you can see here, this is plot number 5, meaning there's a lot of changes that we've been making step by step. And all these changes have now led to model number 4, which will be in plot number 5. And this will technically be our last plot and hopefully the one that visually looks the way we want it to look. One thing to note is that all this other stuff is pretty much staying the same. You can see that the legend title is age of employees, which is good, something we want. But for the MDRT values, because we have recoded things in the way we want the data to be displayed, the option all is something that you should probably select for this. So you'll see there's other options to choose from if you press F1 help. But here I'm going to use the option all because I've already created my grouping variables. So I want the program to use all of them in at least the way I see fit. So let's run this last plot now. And there we are. We can pretty much see here. I'll try to zoom in a bit. This is pretty much our newest plot in its entirety. We have 2 plots, one for males, one for females. And we have overall job satisfaction along the side, low to very high friends at work at the bottom. But then since we recoded age of employees, we can see that that's being accounted for here. So the red is 20 to 39 and the blue is 40 to 59. But yeah, so that's pretty much how you do a 3-way interaction plot. You can see it's a bit different than a 2-way because you've added a new dimension to your plotting procedure. But to get a visual idea of how it would look, this is pretty much how you would do it. I hope this video was informative and helpful. If you have any suggestions or things that you would see more convenient to do with these types of plotting procedures, please let me know. I'm always looking for new methods to at least make what I do a bit easier and efficient. Thank you very much.